tomorrow. Test is tomorrow. Are you going to be ready for another test on which to excel, to paraphrase Mr. McKellips? Yes? Yay. Okay. So, these are the big ideas that I would like you to be down with. As always, the test review is optional. The key will be online, and I will be here before school tomorrow if you have the desire for practice of anything extra. All right, or any more practice on stuff we covered. Differentials. The big idea by far is that true change in y can be approximated by differentials, dy. And that differential, dy, comes from the rate of change, the rate at which y changes as x changes, times an amount of change on x, yeah? That is prevalent in all, or present rather, in all of these types of problems. Now, depending on the variation, this could also be asked something like, if it asks to estimate some new value, then in that case, differentials would be used by starting with a lot like a tangent line. You first find an old value that's close by, and then you say there will be, from that old value, some change to get to the new value. Now that's exactly equal if we need a true delta, but the differential comes in by saying that would be estimated by if we took the old y and used a differential to estimate delta y, like we did above. And then again, you'd roll into that dy is the rate of change times an amount of change in x gives you amount of change in y. Yeah? All right. Then, there are also some other ideas here. If it says, say related error, or related error, relative error, not related error, sorry. If relative error, which is pretty common when you're talking about a physical measurement of something, you know, you measure the side of a physical object and then use that measurement to calculate something else like its surface area. Well, you get error built on error then if you have an error built in the measurement. So the relative error is to take the error itself. I'll say the relative error in some function f. It could be the volume, it could be the area. But the relative error is the error, which is how much your error could change by if you had an error in there, or your volume or whatnot, df, as related to that which you're measuring itself. It's meant to not just find how much error could there be, but is that a lot of error? Well, that's relative to what you measured. You relate the error to that which you measured to say, is that a lot of error? The percent error then would just be the same idea, but making the relative error into a percent. All right? You follow? Okay, good. Thank you. Definition of log. Let me throw out this question and give you a second to think about how you would attack that. If I asked you to estimate the natural log of 3 with accuracy within 100, how would you do it? Okay, I assume by your silence you're thinking and not you're confounded, right? Okay, in the case that maybe there's one person in the room that doesn't know what I'm talking about, let's talk about, you would start with the definition of natural log. And I'm talking the calculus definition of natural log. The calculus definition is the area under 1 over x, or I'll use 1 over t for a dummy variable because it needs to be up from 1 over to some point. In other words, if you take the 1 over curve and go from 1 up to any point, that area equals the log of x. That makes sense, because the antiderivative would be log of x minus log of 1. What's log of 1? 0. So it makes sense that that's now. The goal is not that you actually anti-differentiate that, but then you would estimate this using either rectangles. Now, it would be hard to use rectangles because you couldn't be sure if the error was less than 1,000. We don't have an error bound for rectangles. If it said with accuracy within 100th or something like that, you'd have to use a method you have an error bound for, which is trapezoids. Okay? You could also use, if they didn't say error, you could also use Simpson's rule, which would be actually the most accurate. All right? By far, though, to get even started in the problem, you can't estimate the log of 3 if you don't know that the log of 3 means the area under the 1 over curve. You with me? Okay. Also, unrelated, second idea is the fundamental theorem of calculus part 2. It is the idea that the derivative and the antiderivative knock each other out, right? All right, so if you went from, let's just talk most generally. If you took the derivative of an integral from some constant up to, doesn't even have to be x, it could be up to any function with some interior function here. How does this work out? The derivative of the antiderivative is just a function. Is it g or f? It's the original function with this put into it, yeah? And if that's a function, not just x, then you would also have this chain rule idea, so you'd have to take the derivative of. Let's talk an example here. What if I gave you the derivative of the integral from 3 to x squared of cosine of 3t dt? That says 3t dt. What does that equal to? Cosine of 3x squared times 2x. What about this 3 here? What if it was changed to a 5? Not change anything, that's no effect. Okay. All right, good deal. Volumes of known cross sections. First of all, before you even get started, I beg you, read carefully, please. There could be 4 possible statements. It could be parallel or perpendicular. It could say parallel to the blank axis or perpendicular to the blank axis. And it could be parallel or perpendicular to the x or y axis. If you misidentify the type of base segment, then you're going to go off in the wrong direction. Okay, so if it says parallel to the x-axis, make sure you draw it accurately. I do expect you to draw this, at least if it's a problem of mine on the test, I have a point built in for the rubric for drawing. If it's an AP question, they usually don't. So just to be safe, you should draw it, right? Second, the big idea by far is it's the sum of many cross sections. So it's either going to be area of a cross section times dx for the thickness, or the area of a cross section times dy, depending on if they say they're perpendicular to the x-axis or parallel to the x-axis. That's what determines the dx or the dy, is when they say the segments all run parallel to the y-axis. If all the segments run parallel to the y-axis, then you're looking at ds. If it's square, that's pretty easy. The area of the cross section is just an edge squared, dy whatever. If it's rectangle, then the area of the cross section would be obviously base times height. The base will always be the segment length. This will be the segment length, which is determined by the curves. The height, they would have to give you something about the height. Either the heights are always 2, in which case you could do that geometry, or the heights are always twice the base, in which case you would say the area is base times twice base, or 2b squared, right? So those are all variables. If it's semicircle, then what's the process? Pi over 8 of the diameter squared d whatever. Okay. If it's equilateral triangle, then it's root 3 over 4 of a side of the triangle squared, which comes from 1/2 AB sine C if you get stuck. And sine of C is sine of 60, so that's where the root 3 over 2 times 1/2 root 3 over 4 comes from. And then isosceles triangles, it's usually best if you go base height divided by 2 there, but they could it could be the leg in the base and the plane of the base, or the hypotenuse in the plane of the base, so they're case by case. Okay, you with me? All right. Be able to do those with or without a calculator. But if it's without a calculator, I would have to make the functions pretty doggone clean, yeah? All right. Absolute value derivatives. As always, go understand piecewise. Talk about to find where the absolute value takes effects. You would first need to know where is f equal to 0, and then when is it positive or negative, and that's how you then decompose it into its positive and negative or pieces. Yeah? Could be either this case or this case. What is absolute value on the whole function do? Y is positive, flips positive y's. Okay? What is absolute value on the x do? It's not about up, it's not about everything flipped above, it's about right, left alone, and the left looks like the right. You with me? Because the absolute value would change negative x's to positive x's. Negative x's would be made to behave just like the positive x side. So the left side would mirror the right side. You follow? Okay. Be able to find, mins and maxes, critical numbers, etc. Trapezoid with a sprinkling of midpoint and Simpson's rule. For trapezoids, you should be able to estimate an integral using trapezoids of equal subdivisions. When you do an integral estimate using trapezoids, then you have a greatest common factor or 2 out front. What's out front? 1/2 and the delta x. Okay, so 1/2 delta x out front, and inside starts with, say we went from A to B, then what's your first y value? F at your starting value A. Okay, you start at the left end point. Then your next would be 2 f at every interior values. So I guess you could say your starting point plus 1 delta over, that would be 2 of those, and you continue to get 2's until you finally ended at the right end point. Use the left and the right end points. You with me? Okay. If I asked you to estimate integrals using trapezoids of unequal subdivisions. Think a table, for example. Well, then there's not as much factoring. There's not a common delta x, no common factor, at least not of delta x. I guess you can factor out the half. So you typically just do all traps separately. And obviously, the area of a trapezoid is that, right? That's okay. You should be able to find the error in your estimate, though you do not have to study the formula. I'll give you the error-bound formula. Please be clear about your M work. M is the max concavity measure, or the max of the absolute value of F double. Okay? On the interval, sorry, on, not forever, just on the interval you're working. You should be able to find the number of trapezoids required to get some precision given. If I said estimate natural log of 2 within 10, how many trapezoids would you need? Let's do that real quick. Estimate the natural log of 2. How many trapezoids? So the error is less or equal to b minus a cubed over 12n squared times n. What's b minus a? Error less than, what did I say, 110? B minus a is? Actually, let's start with the integral. Natural log of 2 is equivalent to the integral 1 to 2 of, I guess you could say 1 over x dx. You could use t if you like, whatever you want. Okay, do you agree that is the definition of log of 2? All right, so what's b minus a? 2 minus 1 cubed, or 1, yes. N, what's n? You don't know, that's what you're looking for. M, to find n, you need the second derivative. What's the original function? Is it log or 1 over x? It's 1 over x. You're talking the area under 1 over x. So f prime is negative 1 over x squared. F double is 2 over x cubed. What is the max of 2 over x cubed on 1 to 2? 2, because it's greatest when x is at its least, which is 1, so that's 2. So m is 2, yeah? I need this to be less than 1/10. The error is actually way over here, but if the error is less than this error bound, and this error bound is less than 1/10, then obviously the error would be less than 1/10, right? So if I solve that, then n squared is greater than 1 times 2 over 12 times 10, so something like n squared is going to have to be greater than 5/3, so n is greater than the square root of 1 2/3. So I would imagine 2 trapezoids would do it. Okay, you with me? All right. Volumes of revolution. So then you would proceed on and actually do the estimate of 2 trapezoids. Let me go back here. Find trapezoids to estimate some precision. Check. Be able to tell me if trapezoids over or underestimate. Trapezoid over or underestimate is about concavity. So use the second derivative sign to determine. This is an overestimate because I use trapezoids on a concave up function because f double is positive. Yeah? Last but not least, actually not last but not least, one more thing, midpoint. Be able to use midpoint, it's actually pretty doggone precise. It over or underestimates also based on concavity, but the opposite way. A trapezoid would overestimate a concave up curve, but a midpoint would underestimate a concave up curve if I drew that well. That's why Simpson's rule comes about, because it uses that fact that the true value is between midpoint and trapezoid, so it averages them. Simpson's rule will be given some number of subdivisions, always an even number, and it is 1/3 of delta x times f at the first endpoint, then 4f at the next, then 2f at the next, and it oscillates between 2 and 4. It'll always end in 4 and then a single f at the far. Okay? Cool? It's the most accurate of all the measures. Last but not least, nope, not last but not least, set 94, volumes of revolution. Just, gosh, please give me a picture. Please, it's got to be positive answers. If you're getting a negative, it's because you did it wrong. Don't just change your answer to positive. That takes me off. Find why it's negative and fix that. If you use right minus left and upper minus lower to make positive, you will generally be in good shape. Could be washers, discs, or shells. In some cases you might have options, but in some it's just the function is just too nasty to use one. All right, Newton's method. I did Newton's method on the last test, but Newton's method today I want to focus on being able to apply it to a less than obvious case. So towards that end, let me explain. Newton's finds zeros, right? And Newton's method, in case we need review, it's x initial plus or minus. Minus. I'm starting to get some people slipping, all right? And is it f over f prime or f prime over f? All right. Now, if you did not remember that, you best study that, because obviously a sign error or the derivative in the wrong place will cause you to get a bad estimate. But be able to apply it. If you look at the first problem on the next page, you'll see what I mean. It says f is x squared and g is cosine of x, I think. And it says find the intersection. Now that's not a zero problem. And therefore it needs to be adapted if we're going to use Newton's method. What would you do? If you want to find the intersection point between x squared and cosine, first objective is to make it a Newton problem. So what would you do? Okay, so you say subtract. I'm actually going to go one step closer. Do you agree that we need to find where they meet, and therefore they're equal? And then you say subtract one. Now that makes sense because that makes it a zero problem. And then probably give it a name. What would you name it? So it would be tempting to call it f, but what's wrong with that? Yeah, let's take it. So I would probably call it h or something. You'd say let h equal blah, blah, blah. Okay? It's just that math to use reference to the first hash and tendency. Cool. That practice is in the wrong place. Sorry, that was supposed to be in the wrong place. That's all. Are you going to kill this test? Yes. Test homicide. Pesticide, whatever. I don't know. Think of something. All right. So, okay. Now here's the deal. I got a little problem, so you can maybe help me out. Are you willing? Okay. That's all I can ask. I was hoping you'd just say yes. So, it hasn't been a great day either. Okay. But and I'm kind of tired. And more importantly, you're kind of tired because you have term papers, yeah? And this class is late anyway, because you never speak. And it's the end of the day, and this is one of the hardest lessons I have to teach. And so I'm feeling like it's just going to be disastrous. It's going to be disastrous. But we're going to rise to the occasion, all right? We're going to do our best. We're going to gut it out. But I will warn you, this is a standard deviation. This is not what I warn just your class. I warn every year I ever teach this. At the end of this lesson, you will not have a clue of what I'm talking about. Okay? Except maybe one of you. And then when I teach it the second time, maybe about 5 of you know what I'm talking about. And then when I teach it the third time, we'll get up to maybe 9 of you. And we'll just keep teaching it until I finally, that last student gives me, then I will be done. Okay? But my point is this is hard. And it is very abstract in nature. And so just stick with me. And if I understand especially that somebody in your shoes, you've never felt, I wonder if you've ever really felt confusion. I mean, you guys are just freaking brilliant. I mean, everything just comes right. Oh, I get it right away. Okay? Yes, it is. You guys are always just, you guys, your idea of failure is not failure. I mean, gosh, you guys don't know. You guys don't even know how smart you are. But stick with me here, because if nothing else, it'll give you some humility. And what those darn pre-algebra kids that can't understand how to add 2 fractions feel, yeah, okay? So, check this out. Would you look at example 1, please? This is a pre-calculus concept, and this is actually taught the second day in most calculus courses in college. And that is just insanely brutal. That's cruel, because more kids drop after this lesson in college than any other. Because they haven't even learned calculus, and they're already boom, slammed with this crazy high-level thinking. All right, so check this out. The limit, the first limit. Give me a second. Don't shut it out, because if you see the wrong thing, it'll make me cry. All right? Yeah, you don't want that. So I gave that question on the AP exam, and last test 6 on AP, and the 5th of the students missed it, which makes me cry. So what do you say? The limit is? Okay, so let's make a table. Yes, let's make a table. Would you put 0 in the middle? Yes, you will. Okay? And when, you thought you had a choice. When x is 4, what's the result? 1. When x is 3, what's the result? 1. When x is 2, what's the result? 1. When x is 1, what's the result? 1. If I were to say, what's the next term in this pattern? 1, 1, 1, 1, 1, 1, 1, 1. What's the next term? You'd probably say 1. And that is, in fact, the limit. The limit is about the approach. The limit is approach, not at. Thank you for indulging me. I know you just threw that out there so I can make the table. Thank you. Okay, now example 2 then. Would you please throw example 2 at me? The limit is? 2. Okay, again, the fact that that is 1 means nothing to me. It is about the approach and the wise approach to, yay? Okay. Imagine again, if I made a table, forget 2, don't care. The table is what rules. And if I looked at as x is 3 and as x is 2.1 and then 2.01, what would I see these y values getting closer and closer? They would be getting closer and closer to 2. They would be approaching 2. That's why we say the limit is 2. It's about the approach, not the at. That said then, example 3, what's the limit? 5. Now I assume that despite the fact I said approach, 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 table, 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 you didn't just make a table, you didn't just approach, you went straight there. Yeah? And you said you didn't.
I just didn't fill it out. So you can
All right, so 5. Now, this is always a fun exercise in core logic. You say that the limit is 5 because you can direct substitute. And the reason you direct substitute it here is because you know that graph is a line and therefore continues, okay? You went straight there because you know it's continuous, right? Okay, how do you know it's continuous? Well, what's the definition of continuity? It's continuous if the limit exists, right? And it's equal to the point. So you're saying that the limit is 5 because it's continuous, and it's continuous because the limit exists, right? Yeah. The limit exists because it's continuous because the limit exists. Now that's called circular logic. Okay, that's circular reasoning. Something proves itself. Now that's bad logic. Limit exists because continuous, and continuous because limit exists. Now, the problem is that that doesn't prove a limit is 5. Just because it is 5 at the point doesn't mean the approach is 5. And you can't say, I know that the approach is the same because it's continuous, because you don't know it's continuous, because you don't know the limit exists. And so that puts you in a little bit of a pickle. How do I prove the limit is something if I can't go direct substitution? Now that's actually the definition of a limit. If you were to do a layman's definition of a limit to your little brother, you'd say, oh, it's, as x gets closer and closer to 2, what do the y values approach? That's the limit. And that's true. But the actual mathematical definition of a limit is a little harder. Okay? This is the actual definition of a limit in any calculus textbook. Okay? Given a function, the limit is L only if there is a delta. If you can find a delta, so that if x minus c is less than that delta, it must follow that f of x minus L is less than that epsilon. That's an epsilon. Now, to prove that, then, you have to prove a limit is what it is, you actually have to prove that that definition is satisfied. And it's really hard to prove that definition is satisfied if you have no idea what the definition really is. And so let's talk about this on a table sense, all right? If, for example, I'll come back to the visual in a second. I don't feel like it really hit like in the last class like I wanted it to, so I think I'm going to try and switch gears and try this from a different angle, all right? What if do you have, how much room do you have? Maybe up here. Do you have room here, maybe? Okay. Okay, let's take this problem and maybe show a table that proves the limit is 5. Okay? Now, let's say then, I'm going to let f of x equal to x plus 1, obviously. Now we want to center our table around 2. Do you agree? And I posed that what do I going to approach is 5, but this is really, we can't say that's 5 because that's what we're trying to prove. Okay? Now, say I started by saying, well, you know what? If I get pretty close to 2, that's approaching. Say I put in 3. If I put 3 into the function, what do I get? 7. Now, if I do this in a symmetric way, then instead of 1 above, I'm going to go 1 below, which would mean 1. If I put 1 into the function, what do I get? 3. Okay? Now, my first proof is to say, see, 5 is between 3 and 7. And you can then obviously, you can probably anticipate the counter arguments there. Why 5? Why not 6? Why not 5.3? How do you know it's 5? Don't give me that average stuff either. Okay? All right. So the counter argument would be, why not 6? Why 5? All right. So you could say, all right, I'll get a little closer. I'll tighten the window. Say I went 1/10 away. That doesn't show up very well. 2.1. Surely that would throw your dumb 6 argument out the door. If I put 2.1 in, what do I get for the limit? 5.2, I think, don't it? 5.2. What would be the corresponding symmetric value on the other side? 1.9, 1/10 below. Okay? Now, what is, I'm sorry, what is that value? I got lost in my thought. 3, what'd you say, 4.8? Okay, I agree, 4.8, I'm down. Okay? So at that point, you could probably come back and say, now, your second proof would be, see, can't be 6, because it's somewhere between 4.8 and 5.2. I'm definitely getting closer and closer to 5. I passed way, there's no way 6 is next. 7 then 5.2. Why would it be 6 next? It looks more like it's going down. So 5 is logical. Second proof, can't be 6, must be 5. And then the obvious counter argument, sorry if this isn't very note friendly. I just, like I said, I didn't like the notes I had. Counter argument would be, why not, I don't know, 5.1. 5.5. What did you say? It's still in there. Yeah, or 5, well, not 5.5, but 5.1 is. You with me? To which you could say, I forget this, I'll get closer. How about 2.01? If you take 2.01, then what's 2 times 2.01? 4.02 plus 1, 5.02. And if you took the corresponding 1.99 on the other side, that is 4.98, I think. Okay, I'll go with 4.98. All right. Now, again, if you're with me at all, you probably can anticipate what I'm going to say. The person could say, see, that's closer, around 5. Obviously, it's 5.5, to which I can still give it a counter argument. Nope, can still be 5.0004. I don't believe it. All right? So, at some point, you're so sick of this. Forget this. I'm sick of making you a table that constantly gets me there and disproves your stupid assumption, that you want to go general. Just say, you know what? I'm going to call epsilon however freaking close you want me to get, okay? Would you believe me if I got within a billion of 5? Then would you believe me the limit is 5? Okay? Now that billion, that's just a generic epsilon, all right? So let epsilon be how close I need to get f to the limit, which I say is 5, right? Are you with me? Now, in this case, I left off with I was 200ths away, and therefore maybe they said that's not close enough. Right? Now, if epsilon represents the closeness I need to get f to the limit, then another way of saying is the difference between the function and the limit I say is 5 needs to be less than epsilon. I want to get to the stage where the difference between the function and my 5 is less than a trillion, okay, or a zillion, or however close you want me to get, I can get you there. You with me? Now that epsilon is kind of like the question asker's request. I demand that you get me within a billion before I believe the limit is what it is, right? So it's the demand of the asker. Now your job is to show that once they gave you that epsilon, I can figure out an x, or how close I have to get x to 2, so that when I run through here, I get a y value that close. Now that, how close I need to choose x to the center of 2, yeah, I said on the microphone. Okay. How close I need to choose x to the center of 2, that's delta. Now that delta is obviously not the delta you're used to. That triangle delta, where you represent change with, that's capital delta in Greek. This is lowercase delta. It looks like a 8 that got unfinished, or somebody got lazy making an 8. It's actually more of a D, really. It's supposed to look like a D, but it's an unfinished 8-ish to me. Okay? Or an unfinished infinity sign on the side, whatever you like. But that's delta, lowercase. Okay? Now that is the idea. Visually speaking, it goes this way. To say that the limit is 3 because of direct substitution doesn't cut it, because the limit's about the approach. And they'll believe you if you can get a window around 3 that's super duper tight. Then, okay, I'll believe the limit is 3. Now this gap here, this gap is the epsilon. It's the difference between the y values of the curve itself and the limit we say. And we want to get to the point where that gap, that difference between the function values on the curve and the actual limit, is less than some arbitrary tiny microscopic gap. Now, that delta relates directly to, or forces me to use some kind, or that epsilon, excuse me. That delta, epsilon, I keep saying it wrong, that epsilon relates directly to how close of an x value I need to get to 2 to get there. Now this gap here, this gap is delta. And delta on lines, delta and epsilon relate through the slope. I could show this visually, and then we'll look back at the table. If you look at the fact that this line is kind of flat, this line has a slope of 1/2, if I recall. Okay? That means that this little gap in y will actually make a bigger gap in x, because the change in y is smaller than the change in x. Yeah. That also holds true in that table. If you look at that table, the y's were off by a tenth, the x's off by double. So if we're going to make an equation between the two changes or differences, then actually, let's go back here. In this case, when the change in x was by 1/10, the change or the off in y is 2 tenths. So doesn't it seem like the y change is always double what the x change was? And that is true. In general, the delta for lines is always the epsilon divided by the absolute value of the slope. The negative actually throws things off, so you don't want the negative. There's an inverse kind of thing with the slope. The steeper the slope, the greater the delta, and the flatter the slope. All right, so this, let's talk about what a proof would look like. A problem will often look not just find the limit. They'll tell you what the limit is. The limit is 3. Prove. Now, I'm just going to warn you, it's going to be a little bit of an exercise in abstraction here. And the why of it will start to gradually dawn on you. Oh, I can see why that would be necessary. But for now, just bear with me, and it'll gradually click more and more. You start by deciding on a delta. For this to get however close epsilon away, I need to choose a delta based on how this line slopes. Now, in this case, I would say let delta equal epsilon over the absolute value of a half, or let delta equal twice the y precision you demand. Okay. Epsilon represents how close you need to get to the limit. I will be able to get however close you want to the limit by choosing x's within twice of whatever the gap you want. Right? Now, here's the thesis to the paper. Call it the thesis. Right away, you already hate it. Sorry. It's this. If x minus 2, or the difference between x and 2, is less than that delta, it must follow that the difference between y and the limit, which is 3, the y value of 3, will be less than your required closeness. Any arbitrary closeness, within a billion, within a trillion. Okay? Now, this starts to look like those problems we've been doing in the homework. You now assume the hypothesis of the if. We're going to assume that x minus 2 is within that required delta. Now we use our delta. X minus 2 then, if we define delta as being twice whatever precision you ask, then x minus 2 must be less than 2 epsilon. Now we want to show that it must follow, or we can get to f of x minus 3 is less than epsilon. Now, it doesn't matter if you say, well, I'm going to make the right side work or the left side work. Let's go here. Do you agree that I want to get to epsilon, not 2 epsilon? So I could divide the 2 over, and that's positive, so that's a non-issue as far as flipping the inequality. You with me? All right, then by rules of inequalities, we said that's the same as absolute value of a half. A half is equal to the absolute value of a half. And we also said rules of absolute values say that the product of 2 absolute values would be the same as if we multiplied first and took the absolute value. So that's the same as if I multiplied and took the absolute value later. It'd still be a product and it'd still be positive. That distributed is 1/2 x minus 1. Now, this is where it takes a little creativity. You're trying to get to f of x minus 3. Well, f of x minus 3, if I were to get there, wouldn't it be 1/2 x plus 2 minus 3? So how do I get from where I'm at to f of x minus 3? Well, obviously the half x is golden, but that guy, well, isn't negative 1 equal to plus 2 minus 3? And so it must be the case that the difference between the function and the limit is less than epsilon. That should get you started, and we'll pick up on Friday. Test tomorrow, party Friday. Really?
Yeah.
Are you really going to go to the party? Okay. Am I supposed to bring something?
Would you like to?
I'd just like to bring my pretty self.
That's okay.
how about like napkins and stuff?
No, it's not that situated.
Okay, what about this?
We got drinks.
Wow, you guys are party masters. Obviously, you guys have a lot of parties and stuff.
Yeah.
That's ridiculous. Why don't you get to work? Too many parties. All right, well, I'll bring something. I'll bring some baba ganoush.
Mr.
Yes, sir.
Can I borrow a paper clip again?
I'm already. Who signed up for
No
baba?
one has, no one signed
No one signed up for baba ganoush?
Wait, I'm signed up for chips and that.
Just chips.
Wow, you way to go, Stu. A big one or a little one?
It doesn't matter. That's probably a big one.
Okay.
And if you don't bring it,
But my favorite pencil keeps breaking.
Oh, really?
Look at that.
Yeah.
Like,
what
look
is
in
that?
the, like, in it, like, in the light, you can see it's like,
Yeah. Wow. Why is that? That's weird.
yeah.
Bad lead. It's not big. Yes, sir.
So are we still doing lemon tree on Friday, or?
I will probably strip off the harder part of it and teach it after the break. It won't stick over a week, over 9 days anyway. So you
I'm
will.
just wondering because I might have to leave early on
It's
Friday.
fine. You will be fine.
I'm going to Iowa, and we need to decide when we need to leave to get to the airport.
Okay. If you need to leave early, you will not be. You will be fine. Okay. You'll be good. Oh, tell me yes, I did record it.